Good morning. Today we're going to do a quick review of circles and quadratic systems. So let's just take off and refresh our memories about circles. What is a circle? A circle is the set of all coplanar points x with coordinates x and y that are equidistant from a fixed point called the center of the circle. The distance between the center of the circle and any point on the circle is the radius, of course. The standard form of the equation of a circle that is centered at the origin with a radius length of r is x squared plus y squared equals r squared. And if the center is not at the origin, our standard form is x minus h squared plus y minus k squared equals the radius squared again. Okay, so let's just graph some. Of course, we want to get our x squared over here on the left side, so we're in standard form. So this circle is x squared plus y squared is 25. We know that means the radius is 5 units. So even though our center is not on our circle, I like to put a little point in there for it so I can do my counting from there, right? So now I'm just going to go 5 units in all directions from that center. So here will be my points on the circle. And of course, it's not just these 4 points that I'm plotting. It's all points that are 5 units away from the origin. Those will all be on our circle. And this is the fun part, trying to draw a circle instead of a football or an egg. And mine looks like it's going to be kind of eggy here. But anyway, it's a circle centered at the origin with a radius of 5 units. Okay, so here's another one to practice. This circle is not centered at the origin. What would be the center of this circle, or where would be the center of this circle? Remember, this is x minus h squared. This is y minus k squared. This is r squared. So I'm going to actually do this one in red. So h is -1 and k is -2. So our center is going to be -1, -2. And our radius is going to be 4, of course, the square root of 16. So let me put my center for this one, -1, -2. Put it down here in yellow, just so you remember that's not a point on our circle. And then we're going out 4 units in every direction. 1, 2, 1, 2, 3, 4. That's a really bad circle there. 1, 2, 3, 4. So here's what this circle looks like. I mean, pretend like it's actually a circle. You could use a compass if you want to, but you know, we're not in geometry honors anymore, so we're just sketching. Don't feel bad if it's not great. All right, there we go. Okay, that's how we graph a circle given the center and the radius. So what if we're given the center and the radius and we want the equation of the circle? Well, we know that h here is 3 and k is 2. And if the radius is 4, then r squared must be 16. So our equation here would be x minus 3 squared plus y minus 2 squared equals 16. All right, not too bad. Let's see what we got for part B here. We have a center of 4, 3. So, of course, that's our h and our k. Oh, but we don't know the radius. We have a point on the circle. All right, So if you learned anything at all in geometry last year, one of the biggies was you got to draw a picture and see what's going on. So let's do that. Again, doesn't have to be so accurate, but we need to see what's happening here. So let's see what we got. We got our center at 4, 3. So that'll be about right there. 4, 3. Gonna label that. And we got a point on the circle at 2, 5. So I'm gonna say that's about right there, 2, 5. Okay, so let's kind of sketch that circle in there, see what it looks like. I'm going to put a few other points here that are going to help me do that. So here's this circle that is centered at 4, 3, passing through the point 2, 5, and whatever these other points are. I don't need to know what they are. I just need to get an idea of how I'm going to figure out what the equation of this circle is. So what we got here, of course, is x minus 4 squared plus y minus 3 squared equals, and this is what we don't know, r. We don't know the radius, but look, our picture here is going to help us because we can sketch our radius in. There's our radius. And friends, going back to your geometry honors days, what are you going to do to find that radius? You guessed it, you're going to use the distance formula. So the length of that radius is going to be the square root, the difference of the x coordinates squared, plus the difference of the y coordinates squared. Let's see what that turns out to be. 4 minus 2, 2 squared is 4. And 3 minus 5 is negative 2. Negative 2 squared is 4. So the radius length is the square root of 8. Oh, that's nice. So the radius squared is 8. So there's our equation. All right, moving right on. Ooh, now we don't know any points. We don't know the circle. We just got to take all this information and figure out how to write the equation of these circles. So how about for A? What if I rearrange these terms like this? X squared. I put the x terms together, and I'll put the y terms together. And maybe I'll subtract the 30 from both sides, and it'll be on that side. Is there anything jumping out at you here that might help you to come up with this equation of a circle? I surely hope you're thinking, complete the square, because that's exactly what we're going to do. We're going to complete the square for our x terms and our y terms. So here we go, x squared minus 10x. And of course, we got to half negative 10 and square it. So that'll be plus 25. Same thing here, y squared plus 6y. Half of 6 is 3. 3 squared is 9. And then, of course, remember, we got to add not one, but both of these numbers that we added on the left to the right side. So that'll be plus 34. I'm going to scoot it down here so I don't run into my B part. All right, so let's factor this. X minus 5 squared plus y plus 3 squared is 4. So excellent. There's our equation. Let's go ahead for fun, write down what our center and radius are. What's the center here? 5, negative 3, and the radius would be 2. All right, now B, we're going to complete the circle again, but what is the rule for complete? One of the things we have to make sure of is that the leading coefficient is 1, right? And sadly, that's not the case here, but that's okay. We can make it 1. How did we do it before? We just divided everything by whatever that leading coefficient is. So in this case, I'm gonna factor it out and then work back to it later. So, and I'm gonna put my like terms together again. So that'll be x squared plus 2x, and I'm going to leave my space there. To add whatever I need to add to make that a perfect square, and then factor the 4 out of my y terms, y squared minus 4y plus whatever it's going to be, and that's going to be negative 11 plus whatever I end up adding on the left side. All right, so of course here it's going to be 1. In the y terms, it's going to be 2, 4. And so this is where I got to be careful, guys, because I'm not going to add 5 on the right side, because what am I really adding to the left side? I'm adding 4 here and 16 here. So I got to add 20 over on the right side. All right, so let's go ahead and factor these trinomials. We got x plus 1 squared and y minus 2 squared, and negative 11 plus 20 is 9. So now we got to divide both sides by 4. And finally, we're going to have x plus 1 squared. Oops, let me not forget my 4. Oh, no, sorry. I was dividing by the 4. That's what I was doing. Plus y minus 2 squared equals 9/4. All right, so again, what's our center here? Negative 1, 2. What's our radius? 3/2. All right, so finding the equation of circles by completing the square, you can do it. All right, now we're going to move on to systems. So let's just do, let's see, I threw this one in here. It's a quadratic and a circle system. Okay, let's do it graphically. We'll just start here and do this graphically. So first of all, we've got our quadratic, and I don't know, my first thought here is to factor this. This is x plus 3 squared, right? So that tells me that x equals negative 3. That's my x-intercept. It's also the vertex, and it's not stretched or compressed because a is 1, k is 0. So I'm just going to put my normal quadratic points on here to graph this. Over 1, up 1, over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, of course, my reflected points would be here. 1, 2, 3, 1, 2, 3, and here. All right, so let's just sketch that in. There we go. There's our quadratic. Okay, now let's graph our circle. So this circle has a center at negative 3, 4, and it has a radius of 2. So let's put a little small point in here for the center. Negative 3, 4. It's got a radius of 2, so there's a point. There's a point. Point. So here's my little circle. All right. So there we go. All right, we can see there are points of intersection. So I'm going to go on down to the next 3 problems, which are going to end this lesson. I know, thankfully. And actually, I'll do 1 or 2 of those. And then what I want you to do, after I've done a couple of the bottom ones, I want you to come back and verify this system algebraically. And then whichever one of these at the bottom I end up not doing, you can finish it as well. Okay, I'm going to do A, because I know you want me to do that because it's got fractions in it. So here we go. What do you think is the best? What do we have? We have substitution, we have elimination. I think definitely I'm going to use substitution in the case of problem A here. So let's see what we got. We got 9y. So substitution, remember, you solve for one of your variables and then you plug it in to the other equation. So 9y equals 6. So y equals 6/9, which is 2/3. All right, so now all we're going to do, and guys, this second equation here, it's not a circle. It's not anything you need to worry about at this point, actually what it looks like. We're just going to go ahead and solve this algebraically and see how many, if any, points of intersection there are between these two graphs. All right, so we got x squared over 45 plus, and here I'm gonna plug in what I just found for y, 2/3 squared over 5 equals 1. All right, let me go ahead and simplify that numerator up there before I start making any other moves. X squared over 45 plus 4/9 squared over 5 equals 1. I'm going to kind of simplify this. Let me see, am I running out of room here? Yeah, I'm going to do this over here. So x squared over 45. And then when I simplify this complex fraction, it's complex fraction because it's got a fraction in the numerator. So that would actually be 4/9 divided by 5, which, as you remember, is 4/9 times 1/5. So, oops, that's plus. So that's plus, so 4/9 times 1/5, 4/45 equals 1. So now what I want to do is multiply both sides by 45 to get rid of those denominators. So x squared plus 4 equals 45. So x squared then is going to be 41, which means x will be plus or minus the square root of 41. And hold up, because I'm not done. Remember what we have to do to finish. We have to now plug in our x value to either one of our equations to solve for the y values because we're looking for coordinates here, right? And of course, I'm going to use the, well, which equation am I going to use? Oh, well, let's see. I know this, I only got to figure out what y is. So of course I'm going to plug it in here. So let's see. No. Oh, y equals 2. Oh, come on. My brain's not functioning. Y equals 2/3 no matter what x is. So here are my coordinates. Positive square root of 41, 2/3. And negative square root of 41, 2/3. So there we are. There are the 2 points of intersection of those two graphs. And remember, you always have to write your solutions to the system as ordered pairs. Okay, let's see. Which one of these do I want to do now? I think I'm going to do C, and then you can do B, and then go back up and verify algebraically the circle and quadratic we graphed a minute ago. So let's do this one. What are we going to do? Let's factor it. This is a circle and a linear equation, right? So let's factor out a 3 here. That's going to give us x minus y equals 2. So x minus y equals, wait a minute. Oh, x minus, that would be 6. Sorry, guys. So x minus y equals 2. A little slow on the uptake this morning. So x equals y plus 2. There we go. All right, so now I'm going to plug y plus 2 in for x. So I got y plus 2 squared plus y squared equals 34. And I need to expand this, so let's see, that'll be y squared plus 4y plus 4 plus y squared equals 34. So let's combine our like terms. 2y squared plus 4y plus 4, 34. Divide everything by 2. Y squared plus 2y plus 2 equals 17. Y squared plus 2y minus 15 equals 0. Now we're going to factor this. Y plus 5 times y minus 3 equals 0. So that's going to give me solutions of y is negative 5 and y is 3. But remember, I'm not finished. I'm going to go back up to my linear equation. I'm going to plug in those y values. So right here, x is going to be negative 5 plus 2. So x will be negative 3 right here. And when I plug in positive 3 for y, x is going to be 5. So here are my solutions, negative 3, negative 5, and 5, 3. So if you were to graph that circle and that line, those are the 2 points where they would intersect. So one more time, after you stop the video, you're going to go up here and verify your answer for the parabola and the circle, and you're going to do B, and I'll give you those answers in class next time.